Hello, hello, hello.
Yes,
Yes,
sir.
sir. Good evening, sir.
Yeah, good evening, good evening. Again, I'm a little bit late, but let's start. Okay, that is going to be before chat, so that you can enjoy your chat. Okay, so I am putting the screen here. Can you see the screen? Hello,
Yes, sir.
you can see the slide that it is lecture 18,
Confidence interval. Yes, sir.
confidence interval. Okay. Uh, okay. So let's okay. So it's the same thing. Today we'll talk about the some examples and basically before that again we'll go recapitulating. Okay. So basically confidence interval is that an interval where you have to get the value from the sample data to basically you are going to get for the population data. Okay. So uh, and most of the time the popular confidence level are people look for that 95%, 97%, 99%. Okay, that's it. That's why you will see most of the time when it is talked about confidence interval, you'll see that people are talking about 95%. That means it is going to cover 95% of the sample. If you take that, okay, certainly it is going to uh, give you the result or what you expected. Okay, now there are a couple of terms that are used, and we talked already that point estimation. Okay, most likely value of parameter. X bar is point estimator of mu. That means X bar is the mean value. Okay, that is mean value of your sample. Okay, so it is the mean value, whereas mu is the population mean. That means from X bar, you are trying to map basically what is going to be the value of mu. And the range of values is interval estimation, where there is a possibility of capturing the parameter that is called confidence level. That means you are saying that, okay, fine, this is my point estimate, and you are telling that, okay, this is my margin of error, just as if this is similar to your tolerance limit. Okay, in machining or anywhere you give that, okay, that is what you say, that is plus minus. If you say that, okay, that is 10 centimeter plus minus zero point 0.8, that means people understand that it may be higher level is 10.1 or it may be 9.9. Okay, so one is your upper confidence level, similar to that. One is your upper confidence limit, and another is going to be your lower confidence limit. Okay, so and these term, whatever these plus minus values, these are basically called the error, margin of error. Okay, that also we talked about other day. So and we also said that in confidence level, the level of confidence is nothing but it's just a probability that percentage of the interval where a large value will be repeated. That means uh, if you do uh, and sampling and repeated number of times, just like repeatability of any experiment, you are going to get so many 95%. If I say 95% is the level of confidence, that means, okay, you are going to get that 95% of the intervals is going to contain the population mean. That means if you are saying that, okay, fine, from my sample I am going to get the value of the population mean is this, and you say that this is the confidence limit is 95%. That means 95%, 95 of the interval would contain the population mean. Okay, so and all these things are repetition merely. Again, I show you through another example, another drawing, that it is in general, all these are assumed that they are having a normal distribution, all data. So sampling distribution of x bar, that means this is the sample value, okay, and it has got this, and it's okay, and x bar is here, and you can see here that these are all x bar from where you are trying to extrapolate the value of the mu, okay. And here it is, if it is said that it is 95%, that means your 5% is left out, as I said, okay. So 100 minus 95 is 5, and that is basically divided equally on each side. On this side it is 2.5, and another this side is 2.5%, okay. So within this 95%, almost all your expected value of mu would be here, it would be lying here. Now that does it does mean that, okay, fine, you have this x bar value from which you are going to give an approximation value of mu, okay, and 95% of the cases it is going to cover. So the below of the curve are 5 CIS. That means these are our confidence level, okay, confidence interval. That's so. So what does confidence interval give? That it gives a plausible, that means it is plausible, means it is a reasonable value, okay. That plausible means it is a reasonable range, okay, that where your population parameter can lie, okay, basically. And it gives an estimate, as I said, that, okay, uh, when sampling variability is high, that means your variation of the data are too high, then confidence interval will be also wide, basically to reflect the uncertainty. That means what is happening in sampling data, you are having more uncertainty. So similar to that, whatever you predict, okay, that prediction, your confidence interval will be also full of uncertainty, okay. And statistical significance, if 95% of CI does not cross the null value, it is significant at 0.05. All the same meaning almost, okay. Uh, and as I said, that the size of the interval is determined by the size of the confidence level. So if you choose a higher C, you will end up with a larger interval, and vice versa. That means, as I said, okay, if you look here, so if you say this is 95%, that means this range will be little bit higher, okay. And if you say, okay, fine, I want to have 80%, maybe this will be, that will be confidence level will be, okay, that it will be lower in that case. So all these are covered up, and we also talked about this mu x. Now, as I said, in most of the time, we always try to for the common values, right? So, what are the common levels of confidence? Okay, that it is 90%, 95%, 99%. Sometimes people also talk about 97% also. That means if you say it is 90%, that means it is again subdivided. On the left side, it is 5% and 5%. And if you take it 95%, that means here it would be 2.5% and 2.5%. And similar to that, if you take 99%, in that case also, 0.01 is left out. So uh, basically zero point 0.5. So I mean, the more accurate you want to have, that means in this area it is going to be reduce and reduce. While you see that here it is, here it is more, 2.5%, 5% is more. Okay, so uh, here the amount of the rejection, okay, that is going to be higher. So in industry, what is done, okay, if it is said that what is my confidence level, so accordingly one has to be very much precise. That if anybody says that, okay, my machining is so much, okay, if I say my shaft, the dimension is very accurate, yeah, and it is going to give me 99%, that means whatever is rejection, you have to think that in a big lot, it will be only zero point 0.5 and zero point 0.5. Total, it would be 1%. So you have to be very much precise. That means your measurement and everything has to be very accurate, and your machining has to be very much accurate. Whereas you can go to rough machining or other things. If you say my this is 90%, whereas in that case, what you can do is that that, okay, fine, 10% is rejection. Okay, maybe you can go a little bit crude. Okay, so that's the way it is actually determined. And you will see that in industry that Six Sigma term is used many times. Basically, those are nothing, but that is it is taken as if that, okay, fine, if this okay, if this is your mu value, and if there is sigma is the um, standard deviation, okay, that means on this side it would be 3%, 3 sigma, and another side it would be minus 3 sigma. Okay, so rest of the thing will be basically that would be uh, rejected. Okay, we already talked about this level of confidence is the probability that interval estimate contains the population parameter. Now, what I will do, I have already done some homework problem for you with the mean median mode, and again I'll give for the normal distribution also, and also for correlation, covariance, and I will side by side I'll put this homework for this also, and I'll give you the worked out problem examples, so that you can have best feeling about the example. Okay, and once you work out them on your own, then you will get a feeling. Okay, until and unless you solve the problem, you will not get a feeling about them. And as the time is getting shortened, okay, and there will be holidays and all these things, so you better look into those, what I'll be posting. Okay, from today onwards I'll try to. Okay, so you look into those examples from the websites, and try to also work out the homework that are being assigned, so that you can get prepared for your exams, uh, either for midterm or for your final exam. Okay. We talked about this thing also other day, that we said that, okay, how to get all these values. We said that fine, uh, you can have this one you can get from the table. Okay. So if anybody says that, oh, it is 90%, or okay, so if it is 0.9, so you should go, and from the table you should see what is that probability corresponds to what value of z, and that z value is basically uh, it is determined from the table, because in the in the table you will see that one column is for the z, and another column there are the values of probability. Okay, zero point 0.1, zero point 0.2, in that side also 0 0.7, zero point 0.8. Okay, so you have to basically look into that table, and you have to see for what value of z this one, and accordingly you will be able to calculate. So we had already shown some example on that day. So here sees the area beneath the normal curve, or probability. So use the standard normal table to find the corresponding z score. So basically, what you need to do for this kind of problem is that you have to consult with your table, okay, standard normal table that will be supplied in your exam or anywhere, or in your homework. You need to search uh, from the back side of the book. You will see that there are table which gives the standard normal table, and you would get the values, the area under the curve for corresponding to each values of z. Okay. Now, we already talked about this thing also, that mu is the mean, okay, and standard deviation sigma x is equal to sigma over root over n. Yeah, and again, I ask you just to go back and look into the theory part of mean, uh, standard deviation. That would give, and try to have a feeling about the difference between the sample mean and the population mean. Okay. Okay. We already talked about this margin of error, plus minus. Okay. A confidence interval is expressed at mean plus minus m, where m is the margin of error. 120 plus minus 6. The confidence interval may be expressed if it is 120 plus 6, 126. Okay, that would give 126. Here it would be less than 6. I mean, 120 minus 6 is 114. So your interval is in between this. Okay. Now, size of this m is determined by desired confidence level. Okay. And we already talked about this. Higher confidence level means a large amount of error involved, and large confidence interval means that less precision in your inference. Okay. So that is the thing you have to think about. Uh, we already talked about that, if we have the point estimate, that means, suppose uh, you are estimating the population mean from the sample mean. Okay, so that point estimate is from the sample mean. You are trying to have the estimation, and the actual value of the population parameter, if there is some difference, so that the discrepancy, okay, that difference is known as the sampling error. Okay, that means as if your sample didn't give you the accuracy. That means there was something wrong. That's why you did not, uh, or you were not able to get the close value with the accurate, uh, precisely you could not reach the actual population parameter. That's why this difference is basically, the discrepancy is known as the sampling error. Okay. So when mu is estimated, the sampling error is the mu minus x bar. Basically, that's the thing. Since mu is usually unknown, the maximum value of the error can be calculated using the level of confidence. Okay, so that basically you are trying to estimate the value of mu, but you did not get it. So, that value, whatever you get, is that difference is going to give you the error value. Okay. Now, in the next one, we will show how the E value is calculated. Other day also we showed that E is ZC multiplied by sigma x is equal to sigma divided by root over n. Okay. And ZC you have to calculate from the determined from the table. Okay. And when n is a larger value, then S can be used for sigma. That means the sample mean, you can use it in place of sigma. Okay. So the confidence interval, okay, in that case, for a population mean mu would be x bar minus e. Okay, that means that whatever that error value, margin of the error, that one. Okay, so uh, that one, it is the lower limit, and in that side it is the higher limit. Okay, so and e value you can calculate from here. So most of the problem would be just you have to determine you have to find the value of e, and then you use there, so that you can get the confidence interval. Okay, just like other day also we talked about that cost of 32 textbook prices. So okay, so taken from the local college bookstore, the mean of the cost of those samples are okay. So that is told that it is x bar is equal to 74.22. Okay, so he said that at that time it was rupees 74.22. The sample standard deviation is S 23.44, and margin of error E value is 8.12. That means everything is given there. You don't have to calculate the value of E from this kind of equation. So everything is given there. Basically, uh, from there you can set up what is going to be the I mean um, lower limit or the upper limit. Okay, and construct a 95% confidence interval for the mean price of all textbook. Okay, so here you have to build up, and you have to tell. So how it is done? Okay, this kind of problem is solved, that is shown here. Now, 95% of confidence interval for the mean price of all textbooks. So X bar is 74.22, S is given, and E is also given. Okay. So what you need to do is that basically you have to determine what is the left lower limit, okay, that and upper limit, that right end point. So here, as I said, that you just subtract the error value from the mean value, that is 74.22 minus 8.12, you reach 66.1. That is the lower end, okay, left end point or lower end point. And the higher value is what? 74 point, mean value is added with the error, and you get 82.34. So basically your interval is in between this, and it is the lower limit, and this is the upper limit. Okay, so that's the way 95% of the confidence interval is. That means most of the uh, problem is solved here already. Okay, it doesn't give the headache to find what is what corresponding, what is the e value. So you don't have to do all these things. Okay, so that problem is solved. Now, with 95% confidence, we can say that the cost for all textbook in the bookstore is in between 66.10 and 82 point. Okay, so that's what it gives. Now, okay, here is another problem where it is given already uh, that okay, and you can see that here what it is given is that you can see that n value is given 25, and mean value is given 2.86, and sigma value is given. So to uh, to calculate the e value, one has to get one what is z value. So it is also given here. So you can determine the value of e. Just you plug into that equation, and you end up with the value. So your upper limit and lower limit are mean value plus minus 0.05. Okay, this is the value of, so your this population me, okay, that would lie in between 2.81 and 2.91. So with 90% of confidence level, we can say that the mean grade point average of all students in the population is in between 2.81 and 2.91. So it was a problem of GPA. Okay. So I did not put everything here. Just we wanted to basically show how it is solved. Okay, what is the approach? So basically, it was a problem of GPA of a class where the mean value of the GPA was 2.86. Okay, and we wanted to have calculation that with 90% confidence level, okay, or how the mean GPA value is mm, that varies. So what is the lower limit and upper limit? So that has been shown here. Now, okay, we also talked about this thing. It's nothing much. Okay, here is another couple of examples. Uh, Here it was either it was not solved or most of the time only the problems have been stated. So what you will do if this kind of problem comes and how to handle them in exam or anywhere, you should be familiar with. So here is one problem, just to that says a study was done uh, on the proportion of the males and females who participate in athletics. 480 females and 530 males participated, where 170 females participate in athletics and 208 males. What is the sample of females participating in athletics? What is the standard error of the sample proportion of the athletics? Construct a 95% interval for the population proportion of females that would participate in athletes. Okay, here also you have to uh, do in this similar way. Here is one problem of SAT, Scholastic Aptitude Test score. It is similar to GRE or all these things. It is only for uh, uh, undergraduate entrance test score, that is entry level. The mean SAT score in a, okay, that what is that value is 1180. Okay, so you can see here, and the standard deviation is 5. Basically, SAT is here. It is this combination of the couple of exams, just like your GRE, if you know that it is the combination of quantitative, verbal, and aptitude test, and all this. Similar to that, there are there are some papers. Uh, so we don't need to go in details. Just only we look into the problem. So here the standard deviation value is given, the mean value is given, the mean SAT score, and for males this is 1160. So that means what is it is for male SAT score is given along with uh, standard deviation, the mean values. Similarly, for females, the mean SAT score is given along with the standard deviation, right? So, what is the question that what is the standard error for the mean SAT score for females? Okay, and for males, for the difference between the two, form a 95% interval for the mean SAT score. And also another question is form a 95% confidence interval for the difference in mean SAT score between males and females. So it is not solved here. Okay, just you think about it and let me know in your next class how you are going to solve this thing or what value you require. Okay. And this thing is already we talked about that it is nothing, same equation. what it is given is basically it is sigma divided by root over n sample. Okay, so if you want to get this sigma, okay, that sigma is, that is what it is given, that for the population the sample mean will have a standard error of this, so the error will be this much. Okay, now symbol check, we already talked about this. The mean of the sample means, and sigma x is standard deviation of the sample means, also called the standard error of the mean. Now, there are some examples that are shown, that it shows that okay, 95% chance that sample mean is between 55.4 and 68 point, so much normal mole per liter. Okay, for every sample mean in this range, sample mean plus minus 2. Okay, so it shows the example. Okay, and how it is, that is shown here, plus minus 6.6. So this interval just hits the true mean 62. Similar to that, there is also another example. Okay, uh, all these things shows only basically that what is the lower limit and the upper limit. So I'm not going to talk much about in details for this thing. Now, again, we want to skip this thing. Okay. Uh, now, again, we'll work out some problems, but before that, we brush up again what and how to do. What is the standard methodology? So, basically, if your X bar is given, okay, so sample mean is already given. The variability of X bar, that is the standard error of the mean, is that, okay, as I said, that it is sigma divided by root over 1, and probability will be, as for example, normal contribution. The confidence desired is alpha and 1 minus alpha. So we can write the formal interval X bar minus how much? Okay, and what would be X plus minus? That's the thing we have to calculate. So we have to know basically what are these values. Okay, you are saying that okay, it would be within this range, plus or minus. So how to how to determine these values? So the crux of the problem, you have to concentrate only this part. Then you will be able to solve this thing. So in terms of standard errors of the mean, it is shown already that one is that error E. Okay, that is here. It is already calculated. Okay, that one part of error. Otherwise, what is that? It is going to be Z. We showed it, right? If you recall, I mean, so where we are. Yeah, here we are. If you recall, you remember this thing, error. Okay, total error. We showed it that it is nothing but ZC and multiplied by sigma over root over n. So that's what basically it is going to be shown there also. Okay, so margin of error that is being. So yeah, so what it is that we have to, that ZC is what you have to calculate. So once you say that alpha is equal to 0.05, then 1 minus alpha is equal to 0.95. That means basically if you say that, okay, fine, this portion is 0.05. Okay, so you have a curve something like that. Okay, so always draw something like that, then it will be, your concept will be clear, and you understand that this area is 0.05. So that means you are getting this thing as 0.95, this point. Okay, that means you have to get the value of z corresponding to which you get the probability value of this 0.95. So you have to search from the table, and you see there that corresponding z value is 1.96. Okay, and so the lower limit would be 1.96 multiplied by sigma over root over n, and the upper limit will be one, that is zc multiplied by this sigma over root over n. Okay, and that will give you your 95%. So that is the, I mean, main outline of the problem solving. Okay. So again, it is shown that same thing. X bar is normally distributed. We know 95% of all sample means should lie within 1.96 standard deviation of the book. That 1.96 is basically coming from there. As I said, that this 1.96 is nothing, but you have to search from the table. So once you work out this thing, you would see that automatically you can do for other problems also. You solve only one or two problems on your own, and everything will be easy. Okay, so that's why it is said that 2.5% will lie on each tail, because if you take 95%, this side it is, and this side it is this, and it is this one is 1.96 multiplied by this sigma x, which is sigma over uh, root over n. Okay, 2.5% of all sample means will lie in this tail, and another 2.5% will be on that tail. So once you draw this diagram, then your concept will be more clear. That you know that, okay, fine, this is sigma, this is mu, okay, and on this side it is 1.96 sigma x, this side minus 1.96, and not much here, and it is shown. Okay, and if anybody says that, okay, probability here it is 1.1 minus sigma, you automatically understand that, okay, fine, this side it is alpha by 2, this side it is alpha by 2, and okay, and this is what that z value corresponding to that. Okay, so uh, all this problem, after doing this thing, you come up with this at the end, uh, after simplification, you arrive into this. Okay, and you already understand that this, how this thing is coming up to get the value of the upper limit and lower limit. So what should be the lower limit? That you just add with lower limit, or okay, from the mean value, sample mean value, you subtract off, and to get the upper limit is that you have to add up same quantity on each side. Okay, that's what it is told here in this slide. This is lower limit, and this side it is upper limit. Basically, okay, so you can understand this. So that is the confidence interval for population mean using normal distribution. Always remember that all these things are following normal distribution. That's why you are drawing something like this. If it is not normal distribution, then you cannot think about, okay, your all this equation, everything, believe that they are based on the this one, that it is a normal distribution. Okay, if it is not, that means if it is not following normal distribution, you cannot apply this thing. There is one basic, I mean, assumption. Okay, here is one example. Let's say we have alpha is equal to 0.05. That means each side, okay, total it is 0.2. Okay, So it is, if I say 0.05, okay, sure, you know that this total area is 0.95. Okay. And this side it is alpha by 2, that means 0.05 divided by 2. Okay, and other side also, this side will be also 0.05 divided by 2. Okay. So that's the way it has been calculated. Uh, so uh, you can see here that it is z value is this one, and this is sigma divided by root over n, and sigma value has come from here 10. Okay, and n value you can see from there that it is 5. So that's why it is shown as 10 divided by root over 5. And okay, if it is 95%, then ZC value becomes 1.96, as we had shown earlier also. Okay, so okay, so that value is 1.96. So from there, if once you calculate this thing, you will get the value of mu with the upper limit, and this will be the lower limit to have the confidence level. So that is simplified here again here. Okay, and it shows after a couple of steps. Okay, so you have to practice this kind of problem so that you know that it is 144.24 becomes the lower limit, and 161.76 is the upper limit. Okay, so by the way, Dhananjay is here. Dhananjay is not here. Okay, and how about Mobin? Mobin, who are there in the in this class today?
Yes, sir.
Yes, sir.
Yeah, no, no. You okay? I can hear the voice of Mina. And who are the other boys there?
Sir, Pawan Kumar.
Okay, and who else?
Sir, Deepak.
Deepak.
Sajid Kamal.
Okay,
Puneet.
okay, all right. Okay, so this page also mere repetition that what we did earlier, that 1.96. Okay, that is 95%. That's why we are getting this value. And algebraic manipulation, you get up into this. So already we talked about this thing. Also talked about this thing. So, and this lower bound, this much and this much, we already talked about. So, if a random sample of size n is taken from a population with unknown mu and known standard deviation of sigma, 1 minus alpha, 100% confidence interval is given by this. Okay. Here is also another example. Okay. I'll show you another couple of one or two. So only the change from the previous problem is that the n value is different. Okay. Earlier we were talking that okay, n is equal to 5 sigma. Okay, here sigma is same 10. So because of this value got changed. Okay, and you can see that this becomes lower and lower on the lower limit. So here after algebraic manipulation, you come up with, so 147.2, and this value is 155.9. So there is not much into this into details. Only thing you have to only plug in the corresponding values. That means the only thing is that you have to recall or remember this equation and fit into there. Okay, so or otherwise it's just like mechanically you have to calculate, but you should understand why you are doing this thing. Otherwise if some values are changed, or the language of the problem is changed, okay, you may be confused. That's why you have to understand which one is your mean and which is your standard deviation. Okay, so accordingly you can put your values there. Again, another problem, that randomly sampling 100 students for their GPA, you get a sample mean of 3 and a standard deviation of 0.4. Okay. So what is 95% confidence interval? So one has to calculate the standard deviation for x bar by this equation. So you have to remember always this equation, that sigma x is this. And once you get this thing, then your lower limit is what? Lower limit you get sample mean minus that ZC multiplied by uh, okay, then sigma x, that is sigma divided by root over n. So your lower limit is this 2.92, and the upper is that, again you have to take the sample mean and add this one. Okay, so basically what you are doing is that, okay, sample mean, this one is nothing but just ZC multiplied by sigma divided by root over n. Okay, and here it is just nothing. In the other case, it is ZC is x bar minus ZC multiplied by sigma by root over n. So that's the way you calculate the confidence boundary, plus minus, and you get the interval also in between those upper and lower boundary. So another example also, it's you will see that it is only different is this value, and earlier problem it was 20. Just if you look here, uh, you see here that this one was 155 151.6 and n was 20, but for the next problem you would see it is 153 and n is equal 5. Otherwise, there is not much into this. Again, the same thing. Alpha is only changed to 0.01. Earlier, it was different. So 0.01 means, okay, you can understand that it is 0.01 divided by 2. Okay. So that becomes 0.005. Okay, that means you can see there. That's why it is writing 0.995. So you have to go into the table and find what corresponds for what value of Z. You get 0.995. That has been found to be 2.57. Yeah. So whatever I am telling, or when you look into this slide later on, you please go and check there. Then only you get the feeling and the idea. Otherwise, in the exam hall or in other, okay, you will be, you'll get messed up. Okay. So you have to have some practice, that okay, how to get, just like here, and this 0.99, and after again this simple algebraic manipulation, you come up, you see that it is 141 and 163. So these values are getting changed with the value of n and your x bar. So okay, so almost all problems there so far we talked about, they look similar. Only thing you see here, only the n value is changed or x bar is changed. Okay, otherwise it is just routine exercise. You are just taking up the example, taking this equation and putting there. Okay, so there is not much that intelligence you need to put. Only you have to think, you have to understand the language what it is written. Okay. Another example also here I have put it. The reason is just to show you. Otherwise, there is not much in it into it. Here only is you see the alpha is equal to 0.01 and n is equal to 20. Okay. And you see that this is here. Okay. And ultimately, this problem, I'm not going into this inner details because all these are similar. Okay. Only thing that it is just finding out z value and you put there and you get, okay, and then you simplify each equation on left side, right side, and you find the lower limit and the upper limit. Okay, so by which you can easily understand how it your confidence interval is going to be. Okay, so here is also another example. N is here again changed 90-25. Okay, chest circumference from a population of newborns with sigma is equal to 0.7 inch. Okay, that standard deviation value is given and sample mean is given 12.6. So here the 95% confidence interval means you have to again fit into the equation and get 95% means 1.96. Sigma value is already given 0.7 and root over n means root over 25. So you get here 5. On the other side also it is the same. So after doing this algebraic simplification, you come up with this in between 12.33 and 12.87. Okay, so that's the value you have. So, mainly it has been summarized here that in words how all these things are done. Okay. So sigma is known and all these things, how the standard deviation is calculated. Okay, as, and how the values are calculated. So that's all. Okay, so I'll again give you some other problems from the um, for your homework, as well as you also work out, uh, look into the examples so that you can have some ideas. But I would always suggest that you better work out on your own so that there will not be any problem when you uh, are in the middle of the exam. Okay, so with this I end up my class, and we'll meet again on the next week, Monday. So if you have any question or anything, you just let me know. So all these chapters are just it's almost it's a little bit monotonic in the sense uh, it's not that much you need to uh, put much intelligence in this here. Uh, Prior to that, there are some examples, some problems in other where you have to put some intelligence and you have to think about. So just you uh, and also in this week another homework I am going to put for correlation and covariance. Any point or question?
Hello, sir. What is the symbol C representing in this
Pardon?
confidence interval? Symbol C, capital C. What does this represent, sir?
Oh, capital C represent that it is the confidence interval. Okay. There is I mean, it is not used for some kind of it is don't think that it is just multiplication or all these things. Okay, it is just to show that, okay, that this is the range where actually, sorry, uh, where actually your okay, what it means that, okay, within this, if you can keep the value of mu, okay, so that then only you can get the 95% confidence interval. There is no other meaning. It is not just like it is not I mean algebraic multiplication or something like that. It is just
Okay. And how we are getting the ZC value, sir?
pardon.
ZC ZC value, how we are getting?
I am not getting your voice clearly. Hello, can you hear me?
Hello, sir.
Yes.
I'm asking how we are getting the ZC value, like
Oh,
1.96.
I then you did not listen to me when I said that this is 95%. Okay, 95%. This that means, okay, if I say this is 0.95, so you look into the table. Okay, you go to the normal that table that ZC, okay, or Z value. Okay, you remember in the last quiz you also already worked out some problem. Okay, so
Yes, sir.
uh, there, if you recall that, okay, uh, in one column there are some values like 0.8, 0.9. Okay, that's why I'm saying that you look into the table, then it would be more clearer. Okay, next time again also 1 point, then 1.2.0, and on the other side there was something like 0.1, 0.2, and you are finding some values here. You recall? So
Yes, sir. Yes.
so you have to search that where this 0.95 is. Okay, accordingly, you have to search for this Z value. So it is just like a back, I mean, your back calculation. From the table, you are getting some values here. Okay, from there, you are trying to find the value of Z. This is your Z value. Okay.
Okay, sir.
And that's why I'm saying you go to your room and look into the table, and you try to find that this 0.95 where it lies. You will see that it is 1.96. Okay, that's so this 1.96 has come from this 0.95. Okay, so this
Okay,
Z
sir.
value.
Thank you, sir.
Okay, uh, you can recall that this side it is Z. Okay, and another one, that means it is the probability of the area under this thing. So this is 0.95 is there. Yeah. So that's why you again, I mean, work out on your own. You look and go and check the table. Then only you'll be able to see. Similarly, that's why I'm saying that you do one or two problems, then it will be more clear. Just like 0.99. Okay, you go and see whether you are able to get this 2.56. Okay, here it is that 2.7576. Okay, so that ZC, this has come from 0.99. Okay. So you please go and look into that. Okay. Okay, if you do not have any other questions, so we wind up for tonight. Okay, so have a nice time with your chat. Enjoy your time. We'll meet afterwards. Okay. All right. Thank you.
Thank you, sir.
You're welcome.